Hello everybody. In this video we continue our study of functions, and we're not going to cover any new topic with functions this time. Instead, we're going to spend our time combining functions with most of the material we have covered this semester. And the reason I want to do that is because now that we've spent some time with functions, we now know the four main tools of an intro programming class, and those tools are if statements, loops, lists, and now functions. And so what I want to show you is just how the combination of these things can do really powerful things for you. So at this point in the semester, we are now entering the arena of writing really sophisticated, nice, powerful programs that can do fancy things. So we, of course, have plenty of semester left, so there's plenty left to learn, but just these four tools on their own can do really nice things for you. Okay, so they're incredibly powerful, especially in combination. So in this video, I'm going to write one large program for you that involves functions, loops, and ifs, and hopefully watching this program sort of be designed is helpful for you. So hopefully it's illustrative to think through the design of a program, to make sort of a design scheme and then see that scheme in action. Okay, so in this video we will combine functions with most of the stuff we've covered, and we'll do that by writing a program that lets people play the game Nim. I assume you haven't played Nim. Okay, it's a game that really only mathematicians care about for their own reasons. So of course I'll tell you the rules, but Nim is a nice game for programming. Okay, so there's really natural ways for like loops and functions to show up when you have to write that program. Okay, so let's start with the rules of Nim. It's a two-player game. There are n piles of rocks, so just a bunch of piles of rocks everywhere. The players alternate turns, and on a player's turn, that player chooses a pile of rocks, so they have to like point to a specific pile of rocks, and they take as many rocks from that pile as they want to. Okay, so I as the player, I scan across all these piles of rocks. So I notice, oh, that pile of rocks has 6 rocks. That pile has 10 rocks. That pile has 30 rocks, whatever, right? I point to one of those piles, and then from that pile, I take as many rocks as I want. And then you take your turn. You do the same thing. Point to a pile and take as many rocks from that pile as you want to. We continue in this fashion until all the rocks are gone. The winner is the player who takes the last rock. Okay, that's how the game goes. So just as an example here, suppose these are the piles of rocks. There's a pile with 5 rocks, a pile with 6 rocks, a pile with 2 rocks. Player 1 goes first. They choose a pile and take rocks from that pile. So player 1 could choose any pile, but they choose pile 1. Okay, so he can take between 1 and 5 rocks from that pile. If he takes 3, then now here are the piles, right? He took 3 away from the first pile. The other 2 are left alone, so 2, 6, 2. Player 2 chooses a pile and takes rocks away, and so on. You just keep going. So suppose at some point in the future, we're here. No rocks in the first pile, no rocks in the third pile, 3 rocks in the second pile. So recall the winner is the player who takes the last rock. So presumably, if it's your turn, you point to pile 2 and take all 3 rocks away, right? That's how you would win. If you took fewer than 3 rocks away, now your opponent can just come in and take all the rocks and win. So those are the rules of Nim. That's how you play this game. Let's write a program that lets people play this. And since we're in the function material, right, let's just use functions all over the place, right? Let's let all the heavy lifting be done by functions. So with any big programming like a program like this, right, or even a small program, hopefully you are doing this, right? Hopefully you're doing this kind of pre-programming strategy with your partner, or if you don't have one by yourself, right? But articulating what the schematic of the program looks like, right? So just thinking in English about what kind of tasks need to be done and in what order, things like this. So here's the basic schematic of the game. Well, first of all, you have to set up like the game board, by which I mean you need to know how many piles there are and how many rocks are in each pile, right? You need some start configuration. And again, this n is arbitrary. You could have 50 piles of rocks, and the pile sizes are also arbitrary. Like you can just put whatever values you want there. Okay, so but you have to set that up to get the game going. Player 1 takes a turn. Player 1 chooses a pile and removes a valid number of rocks from that pile. So, if there are 5 rocks in the pile, they can't take 10, for example, right? Well, after player 1's turn, we should see if that player just won, and if so, everything's done. So after a player's turn, we should see if all the rocks are gone. And if all the rocks are gone, the game's over, and that player just won. So, assuming player 1 hasn't won, player 2 gets a turn, and same thing, right? The players are symmetric in what they do, so player 2's turn looks a lot like player 1's turn. After player 2 is done, you again also check and see if that player won, and if so, we are done. We continue these steps until all the rocks are gone, and as always, if you ever find yourself saying the word until in English, that's going to require a loop in Python. Okay, so English phrases like as long as or until. Okay, these are giveaways that you need a loop. So that's just sort of like a schematic of what the program looks like. Well, how are functions going to play a role in this, right? Well, remember, a function is just like a block of code that performs a specific task for you. And so, this schematic, right, there are all sorts of tasks you need to do, like check if somebody just won. That's a task, something you need done. So I've listed 4 here. There are many others you could think of, I suppose, right? But set up the game board. That's a task, right? Initially, there's no game board. There's no piles of rocks. You have to tell a computer what your start configuration is. And maybe like a turn taker function. So a function that lets a player take her turn. A game board maybe updater task, right? That updates the board after a player's turn, right? That somehow knows what the player did and updates the game board accordingly. Maybe a function that checks to see if somebody just won. So a function that checks to see if all the rocks are gone. Things like this, This is not a complete list necessarily, right? But certainly you need this kind of thing to happen. Okay, so with all this sort of strategy in place, I'm now just going to show you the program. So the sample code, the code that I'm going to show you, is on Moodle in the sample code section. I'm not going to write it from scratch for you for the sake of time. Okay, if I did that, that would double the runtime of this video. But before I show it to you, let me just say that one of the really nice things about programming, something that makes it fun to do and to teach, is that it's just such a creative enterprise. Okay, so this program, a program to write Nim, there are just like dozens upon dozens of ways of doing that. Okay, so what I'm going to show you is like the way I came up with to do that, but you could come up with a way that looks a lot different. You could have different functions doing different things. So you might have different loops doing different things. I don't know. So all that to say, right, it's just really nice. There are just so many possible solution paths. It's nice to see the kind of paths that people discover. So here's a solution path I discovered that I wrote. I decided to use 3 functions. One of them sets up the board. So let me just give you a brief overview of this before we walk through the specifics. So one function just sets up a board, the game board. The next function just lets a player take his or her turn. So it's a player turn function. That one's kind of long. This is called total number of rocks function. It just counts the number of rocks on the board, right? So it's actually a win checker on some level, because if there are 0 rocks on the board, then whoever just went, that player won. So this function exists just to check and see if the game is over. Okay, so I'm going to walk you through those functions in a second, but notice here's the not function part. It says this, well, first of all, game board equals set up the board, So this function set up board, what it must be doing, right, is returning a game board that's set up. Right, game board here, this is supposed to be a list of the piles of rocks with how many rocks they have. That setup must be happening in this function, whatever it does. And notice it says here, right, as long as the total number of rocks on the board is positive, well, the game hasn't terminated yet, right? So I'm going to print here player 1's turn, and then it says here, player turn. You feed in the board, right? So if you're going to let somebody take their turn, you have to know what the board is, right? You have to know how many piles there are and how many rocks are in each pile, etc. So that gets passed into the function. And then presumably what happens here is after the player's turn is over, there's a new board, right? And that's now here. And then it says here, right, if total number of rocks is 0, tell that player, hey, you won, right? Player 1 must have just won. Otherwise, right, if that's not the case, then print player 2's turn, right? And then just do the same thing, right? Player 2's turn is like the same in terms of the tasks that need to be accomplished. And if total number of rocks now is 0, then tell player 2 they won. And notice when you reach this part of the code here at the bottom of the loop, if there are no rocks left, right, the loop is done because total number of rocks is 0. So the loop will terminate and there's nothing left to the function, or to the program, sorry. So the program is done also. Okay, so let's just quickly go over what these functions are doing. Set up the board, okay? Notice it has no parameters. So you can have functions with no inputs. Notice it has an output though, right? But anyway, you can have no inputs, like there's nothing sort of to hand this function because there's nothing going on yet, right? So the print command though, once the function starts, says give me the list of pile sizes, and let me scroll over, separated by spaces. So I'm just going to grab the list of pile sizes like we've done before, and board is just going to be that list. So the list looks like 5, 6, 13, 10, whatever, right? Where each number is a number of rocks in the corresponding pile. And then I just return that board. So this function accepts no inputs, but what it gives you back is a setup game board for this game. Okay, this next function is called player turn. So in order for a player to take their turn, you have to hand this function the game board. You have to hand it the list of pile sizes, or this function can't run, right? How is the player supposed to take their turn if they don't know how many rocks are in each pile? So anyway, it starts by saying print, here's the game board right now, and you print it. And before you give them a choice of pile, right, notice I am nice enough to remind them that I start counting from 0. So there's actually a 0 with pile, a first pile, a second pile, etc., right? And then I say, hey, choose a pile, right? So remember I'm counting from 0. And notice what I say here, as long as that choice is negative or it's the length of the board or bigger. What have they done? They've chosen a non-existent pile, right? At least in the physical context here, right? There's no negative pile. And there's no pile bigger than the length of the board, So then I tell them, hey, yo, the legitimate pile positions are these, So you can start at 0 and then through number of spots minus 1, right? As with any list. Okay, and then it says, hey, choose a pile again, right? So this loop, right, is going to keep running. It's going to keep telling them this until they choose a pile that actually exists, okay? So again, if there are 5 piles, that means there's a 0th pile through a 4th pile. So if the user types in 5 or 6 or 7, right, we should tell them, hey, just give me a real number, give me a number that works here. Once you have the pile choice, right, they've chosen pile 0, pile 1, whatever, well, now they have to tell you how many rocks they want to take away. Okay? And so again, the number of rocks, right, only makes sense to take away a certain number. You're not allowed to take away 0 rocks. That counts as a pass. You're not allowed to pass. Not allowed to take away negative rocks, Also, you can't take away more than what's there, right? So board bracket M, right? You go to position M and ask how many rocks are there. That's what this is, right? So if they try to take away too many, right? There's only 5 rocks there and they tell you, hey, take 7. You tell them no. Like, I want a legitimate number, So I say, you must take a nubmer, right? Number of rocks between 1 and however many there are, And then make them choose again. So anyway, this is the bulk of the function in terms of like lines of code, But these while loops aren't doing anything fundamental really. They're just making sure the user is behaving themselves, right? Anyway, once the user has made legitimate choice of pile and legitimate choice of number of rocks, then what do? You go to that pile, right? The pile at position M, and you decrease it by n, right? You take those rocks away. Okay, so if they chose 2 here, right? Take 2 rocks away. That's what you're doing. -2 away. And then once that's done, you just give the board back, right? So you've made a change to the board and then just return it back. Finally here, as we mentioned before, total number of rocks. So what's that doing? You hand it the board. This sum is just going to keep track of how many rocks there are in total across all piles. So for pile and board, right? Sum plus equal pile. So you just iterate your way through the game board and add up all of the pile sizes. And you return that sum. So again, if there's no rocks anywhere, right, then these pile numbers here are all 0. So the sum that you return will be 0. You haven't increased it at all. So again, I decided to write 3 functions here. You could have used more or fewer, I don't know, right? So think about this right here, right? This loop is just checking if the pile choice was valid. You could have written a function that did that. Okay, you could have taken that while loop and put it in its own function that returned either true or false based on whether or not the choice was legitimate. So that could have been a 4th function in this program. Same here, right? This while loop, you could have written a separate function that again returns true or false based on whether they're doing something legal or not. So, if they do this, right? Too small or too big, you would return false, right? You'd say, bad. And then you'd force them to choose again, right? So anyway, all I'm saying is, right, there could be more functions or fewer here. There's lots of ways to do this program. Let's just conclude here by running this and make sure it does what it's supposed to. Okay, so 2, 5, 7, 3. Okay, that's the game board, right? And look what it says, right? It says player 1's turn. Here's the board right now. And it knows what that is, And it tells me to choose a pile. So how does it know what that is? Okay, so let's just recall what's happening here. The first real command, right? The first command after all the functions are created is this. Set up the board, right? I don't need to input anything, really, right? Because all I care about is the return, like what it gives me back here. So game board is going to be whatever this function returns. What does that function do? It says this English, right? Give me the list of pile sizes separated by spaces. And then it grabs those and gives them back. Okay, so in other words, right here in the code, the program knows 2573 is the list of piles. Okay, so now I can choose a pile, and notice if I do like a -4, it says, hey man, like 0 through 3 is what you're allowed to do. And suppose I'm obnoxious about it, right? 6. It says no. 8, no. Finally, if I choose like a 2, it says how many rocks do you want to remove? And now I've left with the, okay, so I'm in 0, 1, 2. I'm in this pile, right? There's 7 rocks there. Okay, well, what if I tell it to remove 9? What does it tell me? It says no, What if I say 9 again? It says no, 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 right? If I keep trying, right? Since those are loops, it will not let me leave that loop until I behave myself, so I'll take 7. And now notice, right? It says, oh, player 2's turn, right? Notice the program's still going, right? Because once player 1's turn is over, it does this if statement. If the number of rocks is 0, it says I won. But otherwise, it keeps going. And now player 2 gets a turn. So print player 2's turn. Here's the board right now, right? It recorded what I did as player 1. And I can now choose a pile. Let me just make this fast. I'll choose pile 0, remove 2 rocks. And now it's back to player 1, So after player 2's turn, it's right here in the code. The total number of rocks is not 0. There are still 8 rocks. So it keeps going. So I'll choose pile 1, take 5 away from there, right? Now finally, let me end this. I'm going to choose pile 3. Sure does look like pile 4, doesn't it, right? But anyway, pile 4, or pile 3. And I'll take away all 3 rocks. And now, right, the game's over. I took the last rock as player 2. So I win, and notice it's done, right? So that's really cute, isn't it, that program? So anyway, this is what I would call a more sophisticated program, right? Not only because there's more code, right? And there is more code, but just because the logic is getting more sophisticated, right? So to follow this code just takes more work, right, than following the code from 3 weeks ago. There's a lot going on here, right? The code's jumping all over the place every time it grabs a function. There are loops inside of functions. There are like ifs combined with loops, right? There's this if-else structure inside of this while, and so on, right? But now, right now we are on the cusp of why you would take a programming class in the first place, right? Why do you care about taking a programming class? So you can do sophisticated things with Python, you know? And now we're sort of on the verge of being able to do that, right? So again, by the end of the semester, you will be solving real, like applicable, difficult problems with Python, you know, problems that you couldn't really do on your own. And this program here is not sort of a problem to solve necessarily, right? But it is a, you know, it's a challenge in that, right? Like, how would you teach a computer to play this game, right? Game programmers have to figure this out all the time. Well, now you're like a game programmer, you know. You may want to learn some graphics or something to sort of sexy up the game a little bit, right? But still, this is just a legitimate game, right? Like, you could take this code and just put it on somebody's laptop and they could play this game. Okay, so anyway, so I hope this was helpful for you, seeing more functions and seeing them used to do something a little more powerful here. Hopefully that was helpful.